In this video, we will try to derive the market demand curve while considering the presence of externalities. Here we are talking about the general sense of the externalities, where the outcome can be affected positively or negatively due to some other force. And there are basically two households that we are considering, that is household A and household B. They have their own demand functions, and the commodity that they are consuming is X. So the demand function by the first household is XA, and the demand function by the second household B is XB. It is dependent upon the price of the good X and the income that they have, that is household A, and this depends upon their income, that is IB, and the price of the good. So this is the set of demand functions that we have. For market demand curve, we know that we take the sum of the individual demand curves, which we have done here, and when we do this is simple substitution of XA and XB with the plus in between, and now their unification in this form, where we have taken the common factor, that is 5/4 into Px. Now the positive externalities is the first case that we will consider, and afterwards the negative externalities. So this is the positive externality that we are talking about here, and it is the mutual effect kind of the externality. It means that the consumption or the demand in one household is going to affect the demand in the other household. So XA and XB, so the word mutual is now showing the specific nature of externalities here that we started with as an general form of externalities. So the mutual effect is that the demand curve of good X by household A can be positively affected by the demand of the same good by the household B, and it is the effect is basically the half of the demand which is done by the household B. In the same way, the household B can be positively affected for their demand from the demand of the good X by the household A, and this effect is actually the half of the demand for good X by household A. Now you can see that these two terms are basically added to show the mutual effect. These derivatives can be easily calculated. If you take the derivative of this function with respect to XB, it will be equal to 1/2, because all of this term will reduce to 0 because it doesn't have any XB in it. So only this term has XB, and the derivative of XB will be 1/2 with 1/2 as the coefficient. So 1/2 is there. In the same way, you can calculate the derivative of this function with respect to XA, and here XA is present in this term, so 1/2 will be left and this term will disappear. Now we can solve these two augmented functions because they are augmented with the mutual effect of the externalities, and we can substitute XB here because it is easily substitutable, because these are two simultaneous equations. So I can substitute XB here. So here in the underline you can see the substituted value of XB, which is this value. So this value is substituted here in the equation of XA. Now the next set of steps is basically the simple algebra, in which we are trying to consolidate the terms. Here we can see that XA is appearing here as well as on the left hand side. So we brought this XA term on the left hand side, wanted to merge these two terms of XA, whereas this IA term remained here as well as this IB term also remained there. Now we did the simplification of this term on the left hand side, which was equal to this, and we cancelled out a few terms here, and after cancellation we got this term, which is this expression is actually the externality incorporated or augmented demand function of good XA by the household A. Because this time we have incorporated the effect of the mutual effect of the externality of good B of good X by the household B, and the final result is actually a function of IA as well as IB and PX. These three terms are there in this demand function, whereas the original demand functions without externalities, they were like this, that is, they did not have the income of the other household. XA had only IA and XB had only IB, but now this externality augmented or incorporated demand function of XA is now having IB as well, because now the mutual element is there, the effect from the consumption in household B. Now we can do the reverse, and we can substitute the value of XA here in the equation of XB. Going back to that couple of values or equations, here XB, this equation is what we are using, and we are putting the value of XA here. So this is the value of XA. Now the steps, they are quite similar to what we did in the last demand function of XA. So you can pause the video here and you can see that how these calculations are done. So let's see. These simple algebraic steps, they will lead to this externality augmented demand function of good X by household B, which is not just dependent upon the income of the same household, that is IB, and the price of the good, but also dependent upon the income of the other demand household, that is household A. So now the externalities have been incorporated in XA and in XB. Now we can sum them up to get the market demand in the presence of externalities. So here you see that the sum is to be calculated. This is the value of XM, because this is the sum of the two values, that is XA. This first value in the curly bracket is XA, and this curly bracket contains the value of XB. And now we are rearranging them to find out the value which is consolidated. Here we have gathered IA, and this IA is already here. This IB is shifted to the other side here, and this IB is already here, because we can take the terms of the incomes as common factors. Here we have done this, IA taken common and IB taken common, and then a simplification is done, which you can easily do by pausing the video, and XM is here. This is the value of XM, which is the demand function in the market for both household A and B, where the externalities of the mutual effect, they have been incorporated. And here the externality is positive, but the negative externality is another possibility in the case of this mutual effect, where the sign would turn negative and the remaining expression will remain the same. As you can see, the minus sign is showing that the demand for good X by household A will be negatively affected by the household demand of good X by household B. It is half of this value, half of the demand of good X by household B, so this reduction will take place. Similar holds for XB. Here the negative externality will appear in this way, that is the good household demand by A household will be subtracted the half amount of it. We can take this derivative to see the effect of the externality. Here this equation can be differentiated with respect to xb here, and here the xb term can be differentiated with xa. The answers will be negative because of these signs, and that shows that there is negative externality. Now we can do the same thing of substituting xb here once, and for the other equation I can substitute the value of xa here. So the first thing is to substitute the value of xb here. This is the value that I can substitute, and I have substituted. So it is the same process. You can pause the video and see the difference, and the difference is simply the presence of this minus sign here and here. Whereas if I go back to the positive externalities case, the sign was positive, both in case of xb as well as in case of xa. So simplifying should give us a certain answer. You can do these algebraic steps easily and verify. This is the incorporation of externality, and the demand function will look like this. There's a negative sign here. The dependence is not just on the household income A, rather the other household income B as well. So this is now externality incorporated demand function for household A. For household B, you can internalize this negative externality by substituting the value of xa, which is this value here, and then you can solve this. Once you solve this, you will get this externality augmented demand function for good X by household B, which is not just dependent upon its own income, rather the income of the other household, that is IA. So in this way we have developed the demand curves of both of the households, and this case was of the negative externality. Now we can come to the market demand, which should be the sum of the two demand functions xa and xb. So this is the value of xa and this is the value of xb, and then we have gathered the value of ia and in this case of ib, so that we could take common and simplify it. After simplification we expect to get this answer, and this is the externality augmented market demand function where the externality is negative in nature. Let us do a numerical to put a stamp of validity and verification on it. Here the numerical suggests that household A has a certain level of income, that is $20,000, and household B has income which is $40,000, and market price is there X, and the market price is $5. The market demand for X before externality is this. So in this first expression we are getting the market demand curve without the externalities, and this is the formula that we developed up there, in which we did not internalize any externalities. Let us see. These were the original given demand functions. These were the two values that we are using. So these values are now used in this numerical situation, and we are going to put the values of px, which is 5, income of the household A, which is 20,000, and income of the household B, which is 40,000. We can solve this and we expect to get this answer, which shows that the market demand curve without any externality would be 15,000 units of X. Now if there is a positive externality, the answer should differ. This was the answer in case of the positive externalities, and we can put the values. Once we do this, we are going to get this answer, which is 30,000 units of good X. And in case of negative externality, we expect that answer is equal to this, that formula that we developed in the last step, and simplifying after putting the values will give us 10,000 units of X. So this clearly shows that the original demand, that is the original market demand, is doubled when it comes to positive externality, and it is reduced by a certain amount when it is the negative externality. So the numerical results are in lines with the common sense and the logic that we have developed about the demand and the externalities. This diagram should help us to portray the findings of the numerical that we did. And here you can see that X good, its quantity is plotted on X axis and its price is plotted on Y axis. This is the price that is given, that is $5. So this price is having this dotted line, and this is the demand curve without any externality, and it is represented by D. And this is the demand curve D1, which is with the positive externality, and this is the demand curve with the negative externality. When it comes to positive externality, there is a mutual effect. It means that the demand curve has shifted favorably, that is outwards, due to which the demand has risen from 15,000 to 30,000. So this is quite logical and makes sense that this favorable shift of demand curve is due to the positive externality, whereas the negative externality should shrink the demand curve and it should shift it towards left as shown by this arrow, and consequently at this price the new level of the quantity demanded of good X would be 10,000 units. So this is the depiction of the numerical that we did for the positive and the negative externality. The formulas for which were driven, here we are viewing the formula in case of the negative externality of mutual effect, and here we are seeing the process for the formula of the market demand curve in case of the positive externality of the mutual effect. So this is how we can derive a market demand curve under externalities generally speaking, but in this case the externalities that we refer to were the mutual effect externalities that reinforce or reinforce consequently in a favorable way, or they can reduce in an unfavorable way and lead to positive and negative externalities respectively. Thank you.